Alright guys, today we're going to look at solving equations, what happens when you have variables or letters on both sides of the equal sign. So we're going to do 3 practice problems together to get you ready for today's lesson. So the first one we want to think about is our ultimate goal is to get one variable alone on the side of the equal sign. So this is your order of importance right here. These are the steps that you want to take. Okay, kind of use these steps as like a checklist too. So the first thing you want to do is use distributive property like we've been practicing if it's there. After distributive property, we are going to combine like terms if needed. Then we are going to move one variable, again that variable is your letter, by adding its inverse, its opposite, on both sides of the equal sign to cancel them out. Then we're going to solve as usual. I'm sorry, not to cancel these out, apologies, to make sure that we're moving the variables to putting them with one another. So first and foremost, we're going to look. So do we have any distributive property in this original problem? We have 12k plus 15 equals 35 plus 2k. So there's no distributive property. On the side of the equal sign right here, we cannot combine those because they are not like each other. And we cannot combine 35 and 2k because they are not like each other. So I'm going to draw a line down my equal sign to kind of help me out. Now we're going to move variables to one side. So we have 12k and 2k. So we want to move those k's with one another. It doesn't matter which side we move them on, but you want to kind of help yourself to maybe not deal with negative coefficients if possible. For example, I could move this 12k by getting with negative 12k and put that over here, but then that would give me a negative coefficient. So what I'm going to do is I'm going to get rid of this positive 2k by adding 2 negative 2k's on each side. So these cancel out. So 12k combined with negative 2k, or 12 minus 2, is 10k. Then I'm going to bring down the plus 15, and now what's left over here is just the 35. So we are going to eliminate by adding or subtracting. Remember, we're doing the opposite. So we want to get these 15s integers with this 35. So we cannot combine the 10k and the 15 because these are not like each other. So we're going to get rid of the positive 15 with a negative 15. So you can think about this as adding 15 negatives to each side or subtracting a positive 15 from both sides. Again, however you think about it, those cancel out. Positive 15 and negative 15 cancel out. And now we have 10k on the left. And 35 minus 15, or 35 minus 15, or 35 combined with 15 negatives is going to give you the value of 20. So now we're going to eliminate by multiplying or dividing, basically just depending on what the situation is. So we've made it all the way to a one-step equation. So if I have 10k and I want these k's by themselves, so 10 k's are sharing 20, I want to know how much 1k is, and some people call it one it out. You want to get that k by itself. We're going to do the opposite of multiplying by 10, which is divide by 10. So we're thinking that k is equal to 20 divided by 10, which is 2. So here's my solution, but remember, we can check our answer. And I'm going to check that over here with the blue marker. Okay? So the good thing about these, just like what we've been talking about with our two-step equations, is you can always check your work. So I have 12k plus 15 is equal to 35 plus 2k. Start with your original problem. We're saying the value of k is 2, so wherever we see k, that variable, we're plugging in that positive 2. Now we're going to do order of operations. So 12 times 2 is 24. Then I can bring down that plus 15. And 2, I forgot to plug that in. 2 times 2 is 4. So 24 plus 15 is 39. 35 plus 4 is 39, so it checks out. That means the one and only one value we could substitute for k to make this equation balance on both sides is that value of 2. Okay, let's keep trying some more. So here's my next problem. 3 next to the parentheses a plus 22 equals 12a plus 30. But remember your checklist. Always start with distributive property if it's there, which we do see distributive property. We have that 3 being distributed to both parts right there. So do the distributive property first. So 3 groups of a plus 3 groups of positive 22 is equal to 12a plus 30. So we're bringing everything down that we don't need yet. So 3 groups of a is just 3a. 3 groups of 22 is 66. And then 12a plus 30. Now our next step is combining like terms. So on this side of the equal sign, we can't combine 3a's with 66. We can't combine 12a's with 30's because your variables are not those same as integers. So now we're going to move our variables to one side. So I know that these a's I want to get with these other a's. Again, once you're moving over, you're trying to get the opposite of it. So if I want to get rid of 3a, I have to put 3 negative a's over here. Or I can get rid of this 12a's by putting 12 negative a's on each side. Again, I'm going to do minus 3a or add 3 negative a's to each side because that way I have a positive coefficient. Makes it a little bit easier to deal with. So 3a and negative 3a cancel out. So that gives me just my integer over here. I'm going to do my 66 right here, bring that down. And then 12 minus 3 is 9a. I know that looks like a 9 and then another 9, but it's 9a. And then bring down the plus 30. Okay, so now we have a two-step equation, which is what we've been practicing. So in our two-step equation, we want to get that variable by itself. So we get rid of positive 30 with negative 30. Those cancel out. 66 minus 30 is 36. And this was 9a. So we've condensed it all the way from up here with distributive property and variable on both sides to a one-step equation. And the opposite of multiply by 9 is divide by 9. So that cancels out. So 36 divided by 9 is 4. So we have a prediction that a is 4. But again, we can always check your answer. So I'm going to go over here and write my original 3. A plus 22 in parentheses equals 12a plus 30. So we're going to substitute 4 wherever we see a. And it's really good to do this, y'all, because if you see that there's a mistake when you're checking it out, it automatically tells you you did something wrong, go back and retry it. So everywhere I see the letter A, I'm going to substitute. So order of operations says I do parentheses first. 4 plus 22 is 26. Over here I have 12 times 4, which is 48, and I bring down the plus 30. And here again, we can use our calculators if you'd like to. So you have your Desmos calculator or just your regular. So 3 times 26 is 78 on this side. 48 plus 30 is 78. Because it checks out, that means the only value that I could be substitute to make this equation true, equal on both sides, is that value of 4. So again, check your answers so you can tell us if you got 100 before we even grade it. All right, let's do one more problem together, and then you're going to try some on your own. So our original problem, as you can see, it's getting a little bit more advanced each time. So 3 times the quantity x plus 1 minus 5 equals 5x minus 2. So here again, this is your checklist. So use this as your checklist. These are your checklists or your steps, however you want to call it. So we do have distributive property. We have the 3 being distributed to the x and the 3 being distributed to the 1. The 3, however, is not being distributed to this negative 5 or minus 5 because the negative 5 or minus 5 is not inside the parentheses. So we're going to say 3 groups of x plus 3 groups of 1, bring down that minus 5, and then everything on the right of that equal sign. So distributive property first, and that would be 3x plus 3 groups of 1 is 3, minus 5, bring everything else down. Now we're going to combine like terms. So I'm going to go ahead and do this to help me out. On this left side, we have the positive 3, and think about this as a negative 5, not just necessarily a minus 5, because subtracting a positive is the same thing as adding a negative. So by circling the sign in front of the number, think about that as the integer. So we can combine those together, combine like terms if necessary, and we needed to do that on this part. So bring down the 3x, a positive 3 and a negative 5 combined is a negative 2. The signs are opposite, so we subtract and then take the sign of who there are more of. And then over here we have 5x. I'm going to go ahead and change this up to this negative 2. That way I'm using different colors with the variables and with the integers. So in my third step, move one variable by adding its inverse. So we want to get those x's together. So again, I can either move the 3x's over or the 5x's. I'm going to move the 3x with a negative 3x. That way I have a 2x on this side. Okay, and the reason I like to do that is just so that way it's a little bit easier. You don't have to have everything at once. So over here we had a negative 2 and a negative 2 as well. So now we have a negative 2 is equal to 2x minus 2. So again, we've condensed it all the way from here to now a two-step equation. So I want to get these x's by themselves. So the opposite of a negative 2 is a positive 2. So this cancels out. Well, a negative 2 combined with a positive 2 is 0. And then we have equals 2x. So the opposite of multiply by 2 is divide by 2. And 0 divided by anything is 0. Remember, 0 in the numerator is okay. That just means whatever you're dividing by, it's still going to give you 0. 0 in the denominator is undefined. This one tricks people, but again, you can kind of second guess yourself, but let's check it. Let's make sure we know that this is right. So start with our original 3 groups of x plus 1 minus 5 equals 5x minus 2. Because I'm with you guys. If I saw that, I go, is x really 0? Let me check it out. So 3 groups of 0 plus 1 minus 5.
Good afternoon. Before we dismiss, teachers, please be sure to submit.
So go ahead and try and check that out and see what you guys get.
We'll be writing a report shortly.